Welcome to the crew talk. Make sure to take a seat. There are still some seats open, so don't be afraid. Come and sit. My name is Lukáš. I'm a Scrum Master in Applifting, and today I'll be moderating and introducing these lovely people that will be talking here. I already mentioned there is some refreshments, so feel free to take some. There are some toilets in the back. Also, on this column, there is a QR code. We are surrounded by QR codes. There is a QR code that contains a link to a quiz. If you solve the quiz, you might win a prize. So make sure to do that, and the prize you will receive at 8 p.m. at the entrance. Another QR code is the Slido. It's over there. It's over there. That's for all of your questions about the speakers or about the talks that they will be saying. We will go through them after each of the presentations. Roughly, we will have 2 talks right now, then there will be a short break, and then will be a last third talk. So don't worry, there is a break, so you can also get some refreshments and stuff like that. And with that, I think we can start. We have a little bit of bad news. Our first speaker is unfortunately sick, so he had to join remotely. So it will be maybe a little bit awkward. You will be watching and the stage will be empty, but he will have a camera, so you will see him. And also, don't be alarmed of this phone. He wanted to see you, so we are just using this phone as a camera, so he sees you and you see him, so it works. So yeah, it's my phone. I hope my wife won't call or something like that, but yeah, just an explanation. So with that, I want to introduce first speaker, which is Martin Burian. He'll be talking about Kafka for monolith breakdown, success story. And I asked all of our speakers before about some fun fact from their non-work related life. What are they doing in their free time? And I found out that all of the speakers today are makers. So they, during the day, during the daily job, they make code. But in their free time, they are all making something physical. I think this is a little bit of a therapy. So Martin Burian is able also to do something made out of wood. So he's a maker from wood. Fun fact, I will speak also more about the next speakers. So without further ado, Martin Burian, take it away.
Hi, everyone. Sorry for not being able to talk to you in person. And also thanks to my colleagues for going through the hassle of connecting me remotely. All right. I've been working at Applifting for quite a long time. I went through a lot of positions from like development, mobile development, some infrastructure work, and backend development. And lately I ended up in what we call architecture, or what I call architecture, which means I get to do a bit of everything, which I enjoy very much. And today I'd like to tell you a story of a project that we worked on, where we helped one of our customers to break down a legacy monolithic software system into microservices. Spoiler alert, Kafka helped us with that. And we'll go through what Kafka is able to do, how it can help us, how it works under the hood, to get a better understanding of why it works so well. And lastly, we'll go through some of the application patterns that are useful when you want to implement it and use it in this kind of projects. It all started like this. It's a very usual story. Our customer came to us and they had this huge monolithic application that was backed by a huge database cluster. They had terabytes of data in a highly available database MySQL cluster. And lots of the logic was in the stored procedures that just took data from one table and move it into the other. And they had the obvious problems that development in such a complicated project was getting slow, because you needed expert developers that knew the whole system to be able to make any changes. And they were also running into very high operations cost, because this database cluster just needed lots of performance to run efficiently. And they came to us, and the plan was the usual. We want to carve up the monolith. We want to take it out piece by piece, let's say domain by domain. And in the process, we'd like to transition the operations of the whole thing into something more cloud friendly, which means containers, microservices, this kind of stuff. The plan was simple, but of course it has the usual issues, which means that the domains depend on each other. And because the system was tens of years old, it like wasn't designed to be carved up efficiently, which is what Standard will talk about later. So your product will be ready for that. But right now we need to solve the usual problems of dependencies. The first domain that we wanted to carve away was notification service, which send push notifications and short SMS, emails, this kind of stuff. And of course, the notifications service needs to know about its customers. It needs the phone numbers and contacts and that kind of stuff. So it needs to be able to fetch data from the old system. And on the other hand, the old system also needs to be able to use the new notification service, because let's say the payments module needs to send payment notifications when your payment succeeded, or more importantly, when the company needs you to pay it some money for the notifications that you're about to send. We could do it like synchronously, when the code of the new service calls some API in the old system, but it would not be very robust, and it would add lots of latency and calls and failure points into the system. So we needed something different. We sought something that would help us integrate the services together without having to go through all the audio code. And so we needed this kind of black box that would help us with the integration. The idea here is that because the notifications need to access customer data, we would like to keep a copy of a subset of the customer data locally with the notifications service to be able to access the emails, the phone numbers and stuff. Of course, we need to update this because the customer data is constantly changing in the old system. So we'll somehow need to replicate the changes here. And also we also need to expose an interface for, let's say, action calls from the old system. Well, of course, the syncing might take some time, but we will invoke the magic of eventual consistency and say it's okay. So there's no problem with that. And this black integration box contains Kafka. Well, let's say it doesn't contain it, it's built on it. And right now I'd start with introducing the basic concepts in Kafka, and also get more in depth, because here the details are very important for the actual application. The basic model of Kafka is something like this. Let's say a mental model. You have a server that's running Kafka. Kafka has some topics, right? Where producers write some messages into the topics, and the same messages fall out on the other end and are delivered to consumers, which also come to the server and say, hey, I'm interested in the messages from topic of customer data, let's say. And messages automatically appear in your consumer code. We need to expand on this model a little, go much deeper to be able to use Kafka efficiently. The first step that we need to make is that the concept of topics as queues is, let's say, wrong, because a topic in Kafka is nothing else than a collection of partitions, topic partition. And this topic partition is actually the primitive unit of queuing, let's say. It's a persistent log that's kept on the hard drive, and this partition is the queue that guarantees ordering of messages. So the messages that are written into a partition are then delivered to a consumer in the same order. That does not hold for the whole topic, because a consumer can consume the top of the queue from any partition at a given time. And the partition is also a unit of persistence, because the partition is what's replicated between the servers for storage reliability. That's the next step that we need to take. First of all, there's no one Kafka server. It's a cluster of servers. They are called Kafka brokers, and each broker in the cluster hosts some of the partitions of some of the topics. The partitions, it's not shown in this picture, but the partitions are also replicated across the cluster. So here, this server holds a primary copy of the partition, but other copies are stored on different brokers in the cluster to make it fault tolerant. And the next thing that you can see changed are the consumers, because it's not really as simple as in this picture. There's not a single consumer, not a single instance of a single application that consumes messages from a topic, but there are multiple services where when you write a message into a topic, the message needs to be delivered to all the different applications that depend on this topic. So the message needs to be delivered to our notification service, but later other services will also need to get the updates. And another thing is that the services that consume the messages don't usually run in a single replica. They feature multiple replicas to again provide some sort of high availability, and also to scale the performance of the service while processing the messages. And this model is actually much more difficult to manage, because it raises lots of questions for the consumers and producers and everyone. The producers need to know when they have a message, they need to know which broker to send it to, which partition it belongs to. They also need to know where the partition is hosted. That's the broker they need to write it to. The server needs to make some sense of all the data storage, because lots of data is written into it, and it needs to make sure that it doesn't run out of disk space, because all the messages are directly written to disk, to persistent storage. And the consumers also have their own issues. They need to know which messages from the topic they have already read, because when they restart and start reading the partition, they need to know where to resume, because some messages may have arrived in the meantime. And they also need to know which partitions they will be reading, because each consumer can only each partition can only be read by one consumer in this group, which that's something I forgot to mention earlier. That's this box. This box represents something Kafka calls a consumer group, which is a collection of consumer clients which consume messages from a topic, let's say, in a coordinated way. The most simple way to think of it is that these are replicas of a single service, because our notification service needs to process each message that contains an update of a customer, but it doesn't really matter which replica consumes it. We want to consume it once. So the replicas act as a consumer group, and they divide the partitions between them and then coordinate in consuming the topic. Yeah, right. So all of these questions need to be answered. And when I came to Kafka, it seemed like magic, because I really worked only with the first model, right? You have this cluster of brokers. You point your producer to an IP address and send some messages somewhere, and then they appear on the other side. And I thought, though all of this magic is hidden in this broker cluster, but the opposite is true, because all the magic happens in the clients. All the logic that deals with message routing and uh, the offset storage, which means which messages have I seen, everything lies on the client, and the brokers are really just piping data from one end to the other, storing it and replicating it. But that's all. So to answer these questions that the clients need to know, there are several concepts that are in use. First of the concepts is partitioning, because as we said, there's the concept of topic represents something like a queue, like it's a queue of messages that contain customer data, let's say, but it's composed of several smaller queues, and the message ordering is only guaranteed within this smaller queue, the partition. So we need somehow to make sure that the messages regarding the same customer are processed in the order where we send them, right? Because we don't want an older state update to override a newer one. And this is achieved by partitioning the messages based on a key. Each message in Kafka has, apart from several other fields that are useful, two very primary fields, and it's the key and the message payload. The message payload itself is just the message data that it carries, but the key, which is just a string of bytes for Kafka, but something useful for us, is what determines which partition the message will be written to. Right. So when the producer wants to write a message to Kafka, it takes the key of the message, and based on the key, it computes the partition number that this message belongs to. It uses a partitioner function to assign a partition number to a key. Usually, you can imagine this function is hash of the key modulo the number of partitions of the topic. So it's very simple. But the thing is that all the producers that write data to the topic need to use the same partitioner, because otherwise messages with the same key would end up in different partitions, and we would lose the ordering guarantees for the key, which could break our applications. So the partitioner is configured in the producer, and when you use different producers, usually based on different technology stacks, like Java, Node, whatever, you need to make sure that your producers use the same partitioner, otherwise the data will break. Okay, the next concept that's very useful and that we need to know about is data replication. As I said, the partitions, like the logs that contain the data, are replicated across the cluster to prevent data loss. And when a producer writes a message to a partition, it's directly written to a disk, to a file that backs the partition data. And the brokers are able to replicate the writes across the partition copies, but the producer always needs to write to the broker that stores the primary replica of the partition. And so in the first step, when it wants to write into the partition, it fetches something that Kafka calls cluster metadata, which contains information about all the partitions of all the topics and the brokers where their primary replicas are stored. And the producer knows which broker to send the data to. The brokers also send back some acknowledgements that tell the producer that the data has been stored persistently on the primary replica, or you can configure the client to receive these acknowledgements only after the data has also been replicated to another broker in the cluster, so that you can always make sure that your data is stored and it won't be lost. So this is how the both the consumers and producers know which broker to talk to when they need to communicate with the partition, write to it or read from it. Another thing that the clients need to sort out is that the consumers need to know which messages they have already consumed, because Kafka stores the messages persistently, and we can use this to our advantage. And when our consumer service is offline for some time because of deployments, failures, whatever, and it later reconnects, Kafka can deliver all the messages that came into the queue while it was offline. It uh, some other systems can't do that. Other systems only deliver messages to the consumers when they are online, but Kafka can replay all the messages that were delivered when the consumer has been offline. And the only thing that the consumer needs to do to use this feature is to tell Kafka which offset to start at, right? The messages in the Kafka topic are ordered in a queue, and each message has the number is associated to the number of the row in the log, let's say, which contains it. And when the consumer comes to the Kafka broker, it tells the broker, okay, I need to read this partition of this topic starting at offset X, whatever. And it's up to the client to be able to tell Kafka this offset that it needs to start at. The clients can choose whatever storage they think is best for their application. But luckily, Kafka has a built-in mechanism for this, and the clients can just store the offsets that they have seen in Kafka itself. So it makes a lot of things much easier. And the last concept that's very useful for our application is log compaction, because if we constantly wrote messages into our Kafka cluster, the disks would overflow, and we need to somehow manage this growth of data. One of the things we can do is like delete old messages, which is totally fine if the messages represent just some, let's say, RPCs or events or anything that's not useful later, only useful at the right given time. But there is also another option, which is called log compaction. And it's a mechanism when Kafka deletes old messages that are, let's say, unnecessary, because it goes through the partition and it deletes messages with the key that has been overwritten later, right? So if we have the topic with customer data and we send a message with all the data of our customer, the customer entity, and the key is the ID of this entity, and later we have an update of this data, we just send the message with the same key, and Kafka will make sure that in time, when it starts to run out of space, it's able to delete the older message and only keep the latest version of the customer data in the topic. This is super useful because we can just write the updates. We don't need to take care about anything. We just dump the whole entity into the queue. Kafka makes sure that it only maintains the latest version. It always maintains the latest version. And the only downside is that it cannot guarantee that it only maintains the latest version, right? If you have quick updates, Kafka obviously doesn't have the time to delete the older records, so all the consumers need to be ready to get several messages with the same key, but storage won't be a problem. All right, that's it about Kafka, from very broad concepts to very boring details, but useful details. And now we can get back to our initial problem, where we wanted to integrate a new microservice with an old legacy database and system. And in the first slides, I used this tiny black box, but I need to expand it on it a little because we need to fit several components into the box. And this is what we came up with for the integration, right? The old logic in the legacy database needs to send updates to the new services, and does it through something that's native to it, and that's a database table, right? So we have a database table. Here we call it integration message, and it's a table of messages that the old system wants to send to the new system. And the routines in the old application just write rows into the message into the table and are done with it. They write rows that contain the updated customer data. They write rows that include the calls from the payments domain to send notifications. And then the new system contains a microservice that integrates it into Kafka. The service pulls the database table and writes the new messages into several topics. There are compacted topics for entities like the customers, where we always keep the latest version of the customer data. And there are topics of, let's say, one-off events that are useful for calls between the services. Then the new system is able to read the data from the old and store the subset that it needs into its own tiny database. As the entities are updated in the old system, the data propagates through the table, the service, the queue, and end up here, updating just the subset that is needed for the service. The good thing is that when a new service comes in and also needs customer data, it can just be hooked up to the same customer's topic, read it from the start to the end, and it will automatically get the latest version of the data to work with. And also the let's say RPCs that need to send notifications are routed through the queue into the new system, which adds some sort of decoupling into the system and makes it more resilient. I also wanted to briefly mention some error handling strategies, because obviously errors will come, but I'm sort of running out of time, so I'll just skip through it really fast. The first error type that you need to solve is when your application in a transaction wants to write a message to Kafka, but also needs to remain transactional with your local database updates. And the other problem is when you are consuming a message from Kafka, you need to make sure that when you encounter an error, you are able to to deal with it somehow. All right. The pattern that's useful for solution of the first problem, right, writing the messages to Kafka as a part of a database transaction, is the transactional outbox pattern. It's like very common, but just to introduce it, the producer does not write the message directly into the queue, but it writes the message into an outbox table in the database, and this write is part of its database tracks of the transaction that includes the other updates that it needs to keep in sync with. If the transaction rolls back, the message does not make it into the outbox table, so it never gets sent. Once the transaction commits successfully, the entry in the outbox table appears here, and we are able to, let's say, when our code is hooked to the transaction commit, we are able to send the message to the queue. We need to handle one special case, which is when writing the message to the Kafka fails, and we always need error handling for your error handling. And we can do this by having a periodic job that checks the outbox table for stale messages that were left there before and publishes them, because whatever is committed as a row of the outbox table should be guaranteed to be written to Kafka eventually. The second problem that you can encounter is when you are consuming a message and consuming the message fails because of some error in your application. Now, it's very important to know what kind of error it was. If the error is like a syntactic error of the message, and the message can never be correctly consumed or processed, you need to write it into a special storage. Very conveniently, can be another Kafka topic, which is called the dead letter queue. where the developers can have a look at it and see why it failed and so sort out the error. If the error that caused the application to fail can be fixed, like it's some sort of availability problem with an external service or anything, you can retry the topic. There are two ways you can do that. Either you just try again in the same place, right? You try to consume the message, you fail, you can block the partition for some time, other partitions can continue working, and we can try again later with this specific partition. This is of course very useful for the compacted topics because you need to maintain the consumer position in the topic. Another option for, let's say, the more asynchronous retry is to write the message into a special topic, another special topic, which is called a retry topic. And this topic is consumed by a retry service that takes the messages that have failed and then waits for some time and writes them back in the end of the queue that they came from. And this gives the consumer the option to process the message again with some delay that's configured by, let's say, the retry strategy and by how many messages came into the partition while we were waiting for the retry. Okay, this is just to sum everything up. It's like sort of a nice decision list, which you can use to reference this kind of error handling procedure. And that's about it. Just to end, I'd like to tell you how the project went. The integration through the Outbox table and the Kafka works very well. It handles lots of traffic, no problem. We have already successfully carved out several domains of the monolithic system, and the new development of the new microservices works fine. There are several teams working on them and are able to work at a great pace. And the Kafka never gave us any problem. It's kept up with anything and runs fine. Also, thanks to the people who run it. But for us as developers, it's always worked fine. Also, Tomasz, who helps with the streaming and the technicalities of this presentation, is one of the developers of this project. So you can catch up with him later to find out any particular tips you might have about this. And that's all for me. Thank you very much. I hope it was. I hope it worked out, even though I was connected remotely. Sorry if I took a bit longer than I had, than my time slot was, but that's it. Thanks.
Okay. Thank you very much, Martin. Now is space for some questions. There are some in the Slido. You can scan it. First, I want to give some space to some questions from the audience. Just wait. You need to speak to the microphone. So.
Hi, I actually have two questions. First, regarding how you actually pulled or implemented the outbox pattern. Do I understand correctly that you've essentially added the logic of writing the outbox messages into the monolith itself?
You mean the outbox that
Yes.
is between the old monolith and the microservices? Yes.
Have you considered using something like change data capture instead of writing it manually?
Something like what? Sorry, I didn't catch that.
CDC, change data capture. For example, the museum specifically.
I wasn't a part of that design phase. I came into the project later when we were already running with that. But
okay, that's a tooling you can actually use for that, so that problem is solved. And the second question, I'm not sure whether dead letter queue is actually meant as a retry mechanism. From my experience and from what I know about it, the purpose of dead letter queue is if you have a producers which are producing messages, but you don't have a suitable consumer for them, because let's say you have a consumer and it's not for whatever reason able to consume that message, then it's supposed to enqueue it into that letter queue, but it's not meant as a retry mechanism. The way you do retry is like you don't commit your offsets. That way, if you fail, you end up reading the same message again.
Yes, that's like Maybe I didn't express myself clearly. I didn't mean the letter Q as a retry mechanism. It's a mechanism to deal with failures that we won't be able to resolve with automatic retry. Like when we try to consume the message again, and we know that we can't succeed, there's no point, right? So we just skip the message, and we somehow need to record that this message caused us trouble to be able to go back and fix the producer that wrote the message into the queue in the first place.
Okay, let's right now take a look on the Slido. I think that there are some questions. So first question is, no worries. No, refresh. Okay, is there a way in Kafka to automatically redeliver messages to encounter an error with a wait time? Martin?
With a wait time. Well, as I said, I think that what you can do is you can block at the offset that's giving you errors. You can wait for some time, but it means that data that comes in this partition won't be delivered immediately, but we'll have to wait until you are done with the retrying. But to, let's say, continue processing the partition and retry the message later, I don't think Kafka has anything that can do it natively, which is why we did what we did, why we have the external service that enqueues the message again, because once the consumer commits the offset, it's done with it. It says it's done with the message, and Kafka won't give us any mechanisms to deal with that. We need to do it ourselves.
Okay, thank you. Any other question from the audience? All right, we will switch.
Hello, one question regarding the sequence order of the messages. You said that it is guaranteed that the sequence order is kept within one partition or within the partition. But what if the producer produces like two messages, one after another, and both messages go to different partition? Is it guaranteed that the consumer will receive like both messages in the same order or not?
No, it's not. And it's very likely that it will just receive them in a random order. Because if you depend on ordering of messages, then the messages should have the same key and thus should end up in the same partition. Because that's the definition says that the ordering is guaranteed only within the partition. So if you write one message and then another a millisecond later to a different partition, it's probable that the consumer will, when the consumer fetches data, it gets new data from several partitions, and it's up to the consumer in which order it goes through them. So if it receives the two messages in a single data fetch, let's say, then it's up to the consumer to determine the order of the partitions, which does not depend on the order in which the messages have been written to them.
Okay. Then another question from Slido. Is Kafka-based solution compatible with highest security standards? How are partitions and storages protected from data breach?
Kafka does have some sort of access control built into it, but because we are running in a let's say secure network, and we trusted the components in the network, we did not use that, and I don't really have experience with that. And the data itself is just files on a disk, so the common file encryption and security rules apply there.
Okay, thank you very much. Any other question from the audience? All right. Then thank you very much, Martin, again, for also answering the questions. And now I would like to welcome our second speaker, Standa. And I promise that I will give you some fact what he's doing in his free time. So Standa is actually a sculptor. So he's making things from stone, or at least you can, right? Are you still doing it? Oh, okay, sometimes. Okay, so Standa, and he will talk about the rest, the next talk, and I will remove this. Before Standa set it up, I remind you also that there is the Slido, we will have the QR code, and also there is the quiz. You can fill it, and there is a chance to win some prizes that will be available to collect at 8 p.m. at the entrance. So fill the quiz also to be able to win some prizes. And we will set it up. Nice.
Great.
Stage is yours.
Hello. So, whoosh. Hello. So, my name is Stanislav Gurník, and I work for a company Ruby as a backend chapter lead. As a warm-up question, are here any cyclists, hobby, professional, triathletes? Okay. And how many of you know what Ruby does, actually? I'll say. So, this will come in handy. So, Ruby is basically a computer game for cyclists. So, let's say you are the cyclist, you have the bike, and whatever reason you can ride outside because of weather or something like that, then the Ruby comes here in play. So basically you can have your body control a game which allows you to ride actual roads outside. So what we do is that we blend like those real recording of the routes with 3D world. So we create this like immersive experience when riding your bicycle indoors. If you are no cyclist, but before applications like Ruby came, like training on the trainer indoors for more than an hour was like real suffering. So let's go to the topic of the day. So we are talking about microservices and the monoliths and how to migrate from monoliths to microservices and what architecture to actually choose. So let's be at the year of 2025 and let's ask some LLMs what they think like you should do if you are creating a new company. Let's say some CEO puts the trust in you to choose whatever architecture you want to do. Of course, I choose a little bit like more explanatory to the LLM, not to directly point it to some solution, but more otherwise. But still, one of the LLMs, I think this is Claude, choose microservice architecture. Gemini, microservice architecture. GitHub Copilot with ChatGPT 4.0, also microservice architecture. So it looks like microservice architecture actually like everywhere. Also, you try to Google it from the Google, you probably will get the same result as many of, including LLM's model. Like they want to hook you up on the idea that if you try to use microservice architecture, it will grant you like this infinite scalability and everything you throw at it will just handle and it destroys your technical debt and so on and so on. It's kind of like sounds magical, but the reality with the microservice architecture, more so you are like starting a company can be quite different. Well, there are like lots of problems that are bound to the microservice world. You have to set up the whole cluster for the microservice to work. You have to solve all your DevOps team. Then there's this monitoring and logging and how to interconnect these services, how to use caching. There's like lots of problems. And also, we are talking about monoliths, and some of the problems that typically are bound to monolithic architecture, like context boundary and let's go on. So, actually, I want to say that microservice architecture is not quite easy to set up, but also there is like monolithic architecture which is easier to deploy. You can develop more quickly because you have one code base which you can iterate on. And if you are a startup, that means that you can go to the market more quickly and effectively and be able to more iterate over the application more effectively. And for the business, for the business that is starting, this is one crucial aspect. But the main priority for you should be like design the monolith in the way that is not blocking you to transfer to microservice architecture when needed. And this is what we will talk about today. So, from many years and many monoliths that I have broken over the years for various companies, this is something that I was experiencing, and also Martin was talking about. So you have like this context and boundaries within the system, within the monolith. They were interconnected, all were talking to each other in some ways, calling each other, storages and so on. And this is like the first pattern that is really bad. I'm sure that you all know about it. But first thing for the correctly designed monolith is to actually design a system and context correctly. So they are like really split up. This is not a simple way because many times you will be in the situation and you will not be able to clearly define in which context or system some function belongs to. This is theme for another talk. But this is what your job is, and this is like the most important thing for you to do. So let's say you are successful and you split your monolith, your future application to correctly into the systems. And the next problem that you have to solve is how to distribute information between the modules. And one of the patterns that is actually quite useful, and every language you can think of as some kind of implementation of this, is called command bus, which is actually event system that will allow you to one module to push an event with some data object, and other modules can listen upon that about the event and react on it. So most simple example would be like user is created, and some other module, maybe mailing module, can just listen to that event and send an email that user, a welcome email to the user. The beauty of the solution is that user module doesn't care what happens to that event. It doesn't care simply. The other modules are just listening to that and reacting, and you can expand this system without modifying it. And this is what you want to do. And also, like the subscribed modules may not know who was the original producer of this event. You just don't care. So this is like the distribution of the information inside the monolithic application. And another like added benefit of the solution for you in the later stages will be that you can easily plug this pattern into the messaging system, like Martin was telling about the Kafka. So one of the subscribers to that event in the message bus can be actually the publisher to the topic. So if you later introduce microservices or you decide to pull some module out as the microservice, you can easily plug that in via some messages system. We use GCP and the PubSub. And also vice versa. So let's say you will remove user module from your monolithic application. Same thing, user module will publish the message to your messaging system, which monolith will consume and create the very same event. So again, you are not modifying your monolith, you are just extending its capabilities. Okay, so now we have somehow solved the information distribution in your monolithic application. And now we need to try to solve the reading of the interface of the information. Probably the message you will publish will not be able to will not contain all the data that module needs to work properly. So it needs to some way to read those information. And here comes again. Every language has different naming for it, like facade, interfaces, services. The concept is that you have always some entity in front of your module which defines the interface and clear inputs and outputs of that module. The benefit is, again, later, if you introduce your microservice architecture and you pull some module out of the monolithic application, you will not like change anything in your application. You will just change the implementation of this facade service without modifying any other module that depends on it. Okay, so we end up with the monolith, which may look something like this. So we have modularized it. We implemented command bus. We have facades. If you look at the monolith application that is designed this way, in the, let's say, bird view perspective, and you like compare it to the architecture that is used in the microservices, these two are much same. And so you can see where like this idea of the microservices originates from, and how we ended in the state where LLM tried to push us and Google and all others. So these are like not the concept that they are not new to the programming world. They are here with us for a long time. So let's wrap things up slowly. So the first thing we try to learn is we don't have to start with the microservice architecture with creating new application. In many cases, the monolithic application may be the solution for you. It may not, depends. The correct question maybe is not like what to use, if to use microservice or monolith architecture, is maybe more on how to design the system so those boundaries are correctly set up in your architecture. And we have explained some patterns that you can implement in your monolithic application that can help you later, at a later stage when you decide to move modules out of your monolith, and vice versa. At Ruby, we done both. So we destroyed the monolith into microservices, and also joined microservices back to some like larger applications because of the benefits of the monolithic application. And this was the patterns that actually allow us to do without any downtime, without any sacrifices anywhere. And as I told you before, that these patterns are here for a long time, and the senior developers actually know them very well. So if you are like creating your startup and your organization, you probably want to invest in the senior developer rather than a junior, because he will know that these are the questions that you need to ask if you are designing new application, rather than what architecture it will be done on. These are the questions that will come later, but there are more important things that you have to focus on first. So with that, I want to thank you for the listening. Also, thank for the uplifting, for the organizing the event. Here with my colleagues, senior developers, and also the tech lead. So if you have a question on how we operate at Ruby, how we done things, and what are the challenges we currently have, you have the best opportunity to do so. And as we say at Ruby, keep going.
Okay, thank you very much. So again, space for some questions. So are there any questions from the audience? There's one. So what is your question?
So you came to the conclusion that the architecture doesn't matter and what matters more is people. Aren't you a bit contradicting yourself? Because what you've actually shown is that monolith is fine, but it needs to be designed properly.
Yes.
It's called monolith,
Yes.
this pattern. So that means that architecture matters. You just don't have to go all out at the beginning.
Yeah, correctly. But it's like, the point is matter less if you are starting the company. And what you should do is to choose the architecture that actually suits your needs most. And it may be.
But that's still choosing the architecture. If you are choosing architecture that suits your needs the most, it means that it matters.
Yes.
You said an example like, I think it was creating a customer or something like that and sending an email.
Yes.
That's really nice because this is asynchronous. Sending of the email is asynchronous. You don't wait for the result. But what if you have something synchronous? You have like. You need to create the customer, and then you need to do something, and then you need to return some response to the client.
Sure.
What do you do next?
Well, your client, which is reading the data, needs to be asynchronous also. So there are like few approaches you can use. The most like the stupid thing you can do is pooling. Like you will just try to wait until the real account. The more sophisticated ways is to use some messaging system for the client, so he's notified when the change has come. It's just the matter of perspective. Okay? No? We can discuss it.
Yeah. Okay. There is a question on the Slido, but maybe you already mentioned it. The question is, what about monolith? There's also some there, so do you want to react to that?
Sorry?
The question is, what about monolith?
No, they're basically like terminology.
Yeah. All right.
No.
Any other question from the audience? No. I assume that there will be some conversations happening during the break.
I hope so.
Yeah, which is a nice way of me announcing that thank you very much for the talk again, Standa. And now we will have a short break, so make sure that you have some beer, refreshment and stuff like that. There is a beer over there. There is also some Prosecco. Use the toilet. And remember to sign up for the quiz.
Tak,
Enjoy the break.
jak ti to vrátím.
All right. Ladies and gentlemen, please slowly take your seats back. It's time for the third talk. Okay. Take your seats. Are you refreshed? Have you eaten something? Everybody's okay? Are you... You are not missing anything, right? It's okay. I just want to make sure when you leave, you'll be like, yeah, I eat well, and I learned something, and I listened to some interesting talks. Yeah, you learned something about Kafka. Yeah, not Franz, but maybe also. Yeah. So we are here waiting for a third talk. So I'm real happy to introduce here Jiří Frič, who is also my good friend and my colleague. And you are making something from metal, right?
Yeah,
Okay.
from all kinds of aluminum and other metallic parts.
Cool. Anybody also makes something like with their hands after work? Just curiosity? Yeah, nice. Cool. Continue with that, I think it's nice. So we have here Jirka Frič. Stage is yours.
Thank you so much. Okay, so my parts. I know it's boring part, the documentation of the projects and how to do it. That's why I like this topic. I talk about it also in the DevOps, but now we will focus more on the architecture, on the project documentation, on those parts. And it's something that I struggled for really the entire development life to see any good example of documentation, to see really something that's easy to do and you don't spend really hours thinking into it and not having anything from it back. Before I start, I'm Jiří Frič. I work here in the Applifting as the solution architect, similar as Martin. He is software architect, I'm solution, but in reality it's all the same. He is more focusing on the code, I'm more focusing on explaining why we actually need to do something to the clients. But other than that, we are basically the same. I will have a little bit more interactions with you. I also have a special QR code, if you could scan it. Don't worry, it won't be much questions. It's just 2 questions that I will have on you. You can also raise your hands or interact in any other way. 2 questions, not because I wouldn't have more on you. It's rather that I'm cheap and I didn't want to spend $10 on Slido, so I just went with the free version. So let's begin. Why we are here? Basically, as the solution architect that started as the developer, then I moved slowly to the DevOps and to the architecture. I met a lot of people that see the documentation in really different ways. You have developers that are really like only to have some slide code documentation, few lines in the code. You have architects that we have rather diagrams and stuff around it. Then you have analytics. They have a really, really long documentation, especially in banking industry. And then you also have some other documentation, like strategy documentation that really developers doesn't understand at all. And you need to find some way how to integrate it all together to describe single project in some things that is understandable for all. And I struggled with it for a really long time before GenAI and before any other tools. And that's when my first questions on you will be, what kind of documentations you use on the project? So if you have the Slido, if you could answer. Also, if you have something that I don't have in this list and you would like to just raise your hands and talk about something, it's also possible that you don't use anything at all, that you just why care. I also put there Google documentation. I saw one project that really documented the code with the code examples in Google Docs. That was terrible. So yeah, there is really a lot of different ways how to document. So is there anyone that would just want to raise the hand and talk about something special that's not in here? Maybe completely different? Nobody? Okay, so I will give just a couple more seconds to have more answers. I already see that we have 10 people here, and yeah. I met all of these types of the documentation. Some are better, some are worse. We will get to it. 15, okay. Let's just wait if someone else wants to fill it up. The difference here also is that I consider like OpenAPI part of the documentation. You will see later why. Okay, so 19. Is there anyone else that's still filling it up? No? Okay, so, okay, Wiki and Markdown. Yeah, I kinda expected it. Oh, it's still running, great. Yeah, that's also what I use the most, the code first OpenAPI and Confluence on the third part. I actually expected a little bit more of Drafio, but yeah, there is a lot of tools for you for diagrams, so I kinda get it. And from my side, when I was thinking about all these tools that I use, some in projects, I was missing something in them, because usually when you document by the code or in Confluence, you say that you have it well documented, but in the end, it's really not documented the way you would like that. So I look at the solutions on the market, and I really dislike those tools that are rather manager-friendly than the developer-friendly. That doesn't directly integrate with the work that developers do, that are just sitting elsewhere, like the Confluence, for instance. They don't have direct interactions. Now, lately, it's not that there are already some integrations, but it's really too late, I would say, for these tools, because they are not integrated in the workflow of the development. So I started looking for some team-friendly solution that can really be integrated directly in development, managed in Git, and able to support the work on the code, that you can actually use development documentation to generate some code that you can use in the project. Based on this criteria, I removed 2 options. First is Enterprise Architect, because it's like looking to score in retirement home. They can still do it. They have a lot of experience, but why would you do it to yourself? Yeah, it really can do anything, but nothing at the same time. It's expensive. It's a lot of experiencing to learn it, and it's not something that I would like to push on the developers. Second is the Confluence. It's like looking to score with girl your mom found for you. She isn't compatible with anything you do, makes your life a hell, but your mom likes her because she reads the same novels. And that's from the view of like the managers that really like Confluence, because it's simple for them to use. They can put it there, but for the developers, they cannot integrate it with the Git flow that they use usually in the project, because yeah, you decide to remove some feature branch gets removed, but the documentations for it still stay in the Confluence. There isn't any direct interactions between those two. So I have the second questions on you, and that's what you expect from the documentation. I will keep this running for some time, because every member of the team usually expects something else. Someone wants to learn new stuff from it. Some people want to use it for troubleshooting. Some have it really as the specification of works that needs to be done. And every member of the team, or even the entire company structure, expects something else from it. And for myself, we'll get to it, it was really that documentation shouldn't be something that's done after the code is written, and not even before, that it needs to be directly connected to the development of the code. It needs to be tied closely with it. I will give you a few minutes. I wrote to myself that I need to have something that I can talk about during this slide, because you cannot edit anything on the slide when it's on the screen. And I forgot to really put something to this slide, which I should talk about. So I can explain at least what my viewpoints from the documentations is. I like the documentation that's really easy to read. It shouldn't be just markdown in some files. I like when you can actually render it and you can see it, and when it's accessible for the people outside of the development team, but also when it's in the Git. And we have 16 answers, so we can start looking at them. Okay, so accessible answers, not helpful. Troubleshooting. Okay, so it's the things that we talk about, or what I said, and example usage, yeah, that's also nice. V in PDF. I really like that the Slido doesn't have any way to remove unwanted words. But yeah, my expectation, it should be really a single source of truth. You have everything there, you have it automated, you can use it to onboard new members, you can create contracts between the front end, between the back end, between the services, and you have the critical part documented there. With this, I look how I could actually do it. I started with the cursor. Does everyone here know cursor, the IDE? Is there anyone that doesn't know it at all? Just raise your hand. Okay, few people. It's basically the interface based on the Visual Studio Code, but they really embedded all the GenAI functions deeply into it. So when you write the code, you get recommendations, you can ask it to change some code, you can supply it with some errors that you got from the line of code, and it will directly recommend you how you should change the code. But it's not only for the code, you can use it for the documentations also. So I said to myself, I will create one Git repository next to the projects that we do that will have only the documentation. I put there Open API for specification of the contracts, also Async API and DBML. That's all like contract-based descriptions that you can use to generate the contracts between the components and also for the database. I used the Markdown and also the RAF.io for the diagrams, but you can use anything from Mermaid to Plant UML. And I said to myself that I want all these things auto-generated from the documentation, not have only like the part that's documentation itself, but to also have some SDK for the clients, some server interfaces, documentation unit tests from it, and also mock solutions. So I stopped doing the code-first approach. I rather went with the contract-first approach, that we won't generate the documentation from the code, but the other way around. Why? It's for me, it's better to, as an architect, to see the source of truth between the front end and back end, because if you generate it from the code, you need to rely on the backend side. And if the backend team doesn't have enough manpower to define new components, the front end team can start having the trouble to have something to do in the sprints. By having it separately, by defining things contract first, you just need to teach people really simple open API specification, and both teams can actually work together on it. One thing that I wasn't able to do here is to generate the actual documentation in a nice way, because all know the open API that they have the UI for it, but it's terrible in my eyes. You cannot add additional pages, you cannot build something that's actually nice. But I found one solution, and that's the Sudoku project from Zoplo. And you will see more from it. You can also play around with it later. And you will, okay, yeah.
Yeah, I had a question regarding the previous slide.
Hmm?
You are implying that you've been able to utilize it because certain unit tests and others.
Yeah.
You did it using generative AI.
Not exactly.
Because for open API,
Yeah.
all these generators exist and they are deterministic.
Yeah.
That's what I want to ask, whether you use existing tools or whether you actually use the generative power of cursor. Because that would be non-deterministic, it would open all other.
Yeah, we use those deterministic options, and we embedded additional features to it by the GenAI when we actually need to edit something on the fly, and we can then supply it into it. So when we generate the OpenAPI specification, we use GenAI because some things between the different schemas can be the same, and it can use the one model for the part to generate other parts for it. And I will get to you will see it later in the demo. But yeah, I use this for the documentation, and now I can show you the basic project structure that I do, and also then a little bit demo from it, how it actually runs. So the project setup is really simple. It's just 4 folder specs. That's the specification that I use. Docs that are just markdown files, those things that are then visible in the documentation. Fitness functions and metrics. Fitness functions, I use the cursor for it because they can generate those fitness functions that embed or somehow verify the integrity of the generated files, SDKs, and also it can verify the structure in the specifications. Metrics, that's just to measure the actual deployed code. And with that, I can go to the live demo, just so you can see it, how I use it, and get a little bit look for it. This is something that I also deploy on the GitHub. It's not just completely ready yet. I will just close this for now. When you get to this project, and I will share the link later, you see these like 3 main structures. That's the documentation, functions, and the specification. Specification, as I told, is the OpenAPI schema that you normally know. I use it, the contract first, because in here you can use the cursor and it can automatically start editing things how you like. If you never work with the cursor, you can just select some part of the specification and use it. But also if you generate new parts, like let's call it wait, I will just do it in the schemas. That makes more sense.
Is this a greenfield project, or was the OpenAPI specification extracted from an existing code base?
OpenAPI, I tried both ways. Here it's just greenfield, and
okay, because that drastically changes what what Cursor is able to do.
Yeah. But I'm using it to really just prefer the things that you want, and it can really simply put you additional things into the specifications, and it can actually understand what you do. So this is the simple usage of the cursor cursor that you see here, that you can define some objects, and it can tell you that there is the required specification. What we struggled a little bit at the start was that we have these partial files in the OpenAPI, and OpenAPI schemas are not really defined for this. So we also let the cursor generate specifications that can verify these partial files, because OpenAPI doesn't have these partial files, so we let it to generate these schemas, and then we can use it to match with the paths and the objects that we have here. This all integrates in this central file, but that's the classical setup of the OpenAPI. We also have schemas that's mostly for the naming, and then you can use it for the generation. Here we also have the functions. Functions we actually built directly with the cursor. We know the schemas that we use in the projects, so we write things that do like file name checking and other things. So this all is just generated from the cursor. You put there some of these files that we use, and we write fitness functions that are based around that. The generation of the final code from this is, as we talk about, it's rather more deterministic. You use OpenAPI tools that specify what you should do, and you just run generate, and it's generated by using the OpenAPI generators. And by that you have the complete folder with the SDKs and also the parts for the servers. Good thing about this is the documentation software that I showed you before, because when I run npm run watch, you can have from these files that you set up the mocker that just automatically start. It can use the fake data. So here, if you fill something, and it automatically starts mocking you the data. And yeah, I will just users. This is nice way how you can do it, because here you can add the faker. That's project that you can find on here, and it's just provide you fake data that are really similar to the real. So names, emails, everything can be faked for the mocker. And for the website, you have it running on the local host, and that's the nice part about it, that you have here the API reference. That's all things extracted from the Open API, and you have all these files that you can define yourself, so you can use it here. If you look at the documentation, we have here the pages, we have architecture, and if you change anything, it actually listens, so it automatically gets deployed, and you can write documentation in this way. I like this better because this can be placed in any repository together with the code, and you have not only it in the markdown format that's here, but you can also generate the website from it. And Sudoku is a really nice project, so I highly recommend to using it for the documentation, because now you can, together on the website, you can see not only the API reference, but you can also see the documentations that you've written yourself. Okay.
So, question?
Yeah.
So have you actually used these tools on an existing code base?
On existing, yeah, we use it also.
Because I haven't understand how this helps you, for example, gather the documentation from an existing code and stuff like that. Especially if it's like a distributed system where it's scattered across multiple repositories and things like that.
Yeah, for the collection from the existing software, it wasn't used to gather together the documentation. We rather use it for the new projects when we started, because this way, when we start contract first, we can generate all those things as before, but by using the cursor, we can much quickly build the APIs objects.
How large are the projects and do they run in production?
Sorry?
How large are these projects? You are building cursor and documenting this way, and do they run in production? And for how long?
Yeah, in past work, we built it last spring, but it was before the cursor. It was even released. Then when cursor was first, I think we started it. So without the cursor, this way of how we work, it's running for a year and a half, some projects. But with the cursor, that's only starting now. We are starting to play with it from November, December.
Yeah, probably slightly trolling question. Sorry for that, but imagine that you have like bigger infrastructure, and not single project, but something which is running, huge API gateway, several API gateways. Do you think that this is the way, using this, for example, with Datadog or with some developer portal? Do you have any insights on that? Because we are using Datadog heavily. Datadog is actually quite cool and quite expensive. But what Datadog miss is nice documentation page. And if that will be possible to combine with Sudoku, that's quite a win.
Yeah. I would need to look more closely on the Datadog, how to integrate it. Here I like that because it's all open source, and usually the other documentation solution, they are closed source and you can play with it, so you can extend it by the things you need. You can also, this MDX format, it's just React components, so you can write your own React components for it. I think that there are ways you don't only need to have here one API, you can have multiple. So it's possible to extend for really enterprise-grade projects. It's maybe a little bit too small or not able to manage entire enterprise structure, but if it's 10, 20 microservices, then I believe this is okay, and you can use the extended functions. This is just the basic of it. But if you need more, then yeah.
Thank you.
Yeah.
Does it depend on a specific technology stack, kind of like let's say like a JavaScript backend, and does it make assumptions, or can it work in general with various different tech stacks? Yeah, I'm sorry. Yeah, I'll repeat it, the question. So does it work with with various tech stacks, or is there a specific tech stack that it kind of like works within a specific, let's say, libraries and things like that?
Well, for the Open API, you are limited by what their generators manage, but that's pretty. They support majority of the technology, so there shouldn't be an issue. The Sudoku itself, it runs on the Node server, but you don't need to care about that much. Yeah. Yeah. Any other questions? This was my last slide, also in the presentation.
Okay, thank you very much, Jirka. There was also a space already for some questions. There is nothing on Slido, which is fine. Any other last question? Yeah, sure. Come.
You were speaking about architecture diagrams, right?
Yeah.
Using, did I miss it? Did you show how to create architecture diagrams using?
Yeah, that's one thing that I still struggle with. I know how with Cursor you can create really vague plant UML and mermaid like graphs. It understand it really well, but I don't like them because they are usually really badly looking. You cannot structure them. They are either horizontal or vertical. They cannot really be 2D. So I mostly use just Draft IO implementation in the Cursor, but that's just basic Visual Studio Code. I can show it. Just basic add-on for the Visual Studio. I'm still looking into some other better solution, but I forgot the extensions of the file. But you basically have from the marketplace Draft IO extensions, and you can do it in it, but you cannot use any features of the Cursor with it. So yeah, for the simple things, Mermaid and Plant UML is really nice, but for big diagrams, it's not enough. And I don't know about any like AI fused diagram solution that would work nicely today.
All right. Any other question? Great. Thank you very much, Jirka. And with that, I want to conclude this evening. Thank you very much for participating. Thank you very much for listening. Right now, there is the networking part, so please stay, have a chat with our speakers, with yourself, and I'm looking forward to see you on the next Crew Talk. Thank you very much.